Have you ever wondered, while you're setting up to land in a challenging crosswind, what really causes wind? Well, it's actually pretty simple. In fact, it might be simpler than that challenging crosswind landing. Remember when we discussed the standard atmosphere? Well, now let's take a closer look at what happens when the pressure changes. If you look at the world, you'll see that there are high pressure areas and low pressure areas. And it's the uneven heating of the Earth's surface that causes these high and low pressure areas, which is why there are variations in altimeter settings. Now, since nature tries to remain in balance, the air wants to flow from high pressure areas to low pressure areas. To understand exactly how this happens, let's first talk about isobars. Isobars are lines of equal pressure. Iso from the Greek meaning equal, bar from the vernacular meaning a place where pilots congregate to complain about the wind. Well, actually, bar refers to barometric pressure. Weather reporting stations record and report ambient outside pressure, and then a line is drawn to connect stations with the same pressure. Now, if you look at a weather chart, you could see the isobars along with the highs and the lows. When the isobars are close together, like they are here, the pressure gradient or rate of change between these areas is more dramatic, which means that the winds will be stronger there. But winds aloft don't travel direct. As they move from the high, the winds tend to flow clockwise around the high and parallel to those isobars. And as they move toward the low, the winds tend to move counterclockwise, again parallel to those isobars. Why do the winds aloft travel parallel to the isobars instead of directly from highs to lows? The winds aloft, like most travelers, would prefer a direct route from the high to the low. But in the northern hemisphere, they get deflected to the right because of a force called Coriolis force. Let's take a gander at why this happens. It's like this washer twirling on the end of this string. As the radius of the string gets shorter, the rotation speed of the washer increases while the absolute speed stays the same. Now let's say a very big person were to stand at the North Pole with a rope draped over the Earth to the equator. And let's say there were a great big washer at the end of the rope. If that giant were to pull the washer in towards the North Pole, the washer would begin to rotate faster, just like the washer at the end of the string when the string got shorter. Now, if you were to watch the washer from the equator as it traveled to the north, it would appear to move to the right. If the giant lets out the rope, the washer would rotate more slowly and appear to move to the right as seen from the North Pole. The same thing happens to the wind. When the air moves from the equator northward, its rotation speed increases, so it deflects to the right. When the air travels from the North Pole southward, its rotation speed decreases, and again it deflects to the right as seen from its point of origin. Now, on the surface, friction between the wind and the surface counteracts Coriolis force, so the surface winds move pretty much directly between the high and the low pressure areas. Because of this, as you climb to higher altitudes in an airplane, the winds tend to shift to the right. That's the big picture, but there are also winds associated with local regions. First, let's talk about mountain and valley winds. During the day, the mountain slope is heated, and as the air begins to rise, it draws the colder air from the valley. This is known as a valley wind because the air flows out of the valley up the slope on the side of the mountain. Then at night, the mountain slope cools quicker than the valley, and the reverse takes place. The cooler, denser air on the mountain starts to slide downslope and replaces the warmer air in the valley. And, believe it or not, this is called a mountain wind. Other regional winds are land and sea breezes, and we talked about those already. And now, when you're making that challenging crosswind landing, you can concentrate on your technique instead of wondering what causes the wind.